And now let's move on to the next. And we are going to speak about gray whales' behavior.
What are potential impacts of sea shipping noise on cetaceans? There are different scenarios here. First, there are volume-dependent scenarios or noise level. If it's really loud, it can lead to PTS and TTS, permanent threshold shift and temporary threshold shifts, which basically means that hearing is reduced or fully impaired. If the noise is not as intense, there can be other responses. For example, behavioral changes. Patients can avoid noise or change their behavior patterns. Then there is the masking impact, where noise prevents proper communication between the whales. Or masking can also affect underwater navigation if it relies on noises in the environment. Last type of response has to do with stress, which is hard to measure because visually you cannot observe it usually. Exposed to constant noise, though, animals experience chronic stress. It can be measured by cortisol measurements, the hormone. There were such studies carried out, for example, after 9/11, all ports were closed in the US. So the seas were calm and quiet, which was used as an opportunity by sea researchers. They measured the stress hormone in whales and saw that it had been reduced. It was a unique opportunity. They measured cortisol and corroborated that stress went down, whereas otherwise it affects health and nutritional status. Our study focuses on behavioral responses because you can observe this type of response visually. The conventional threshold here would be 160 decibels for pulsed exposures and 120 decibels for constant exposures, like non-pulsed sounds, which would include shipping noise. Let's take a step back and consider why behavioral disturbance is important at all. So the ship has passed. What's the problem about it? If it happens rarely, this might not be a problem indeed. However, if this impact is constant, if you have this exposure all the time with a lot of shipping, then it could be a challenge. We saw this morning this video from Chile where the poor whale was caught between the rock and the hard place, where ships were all around him. And if whales do avoidance, this negatively impacts their foraging and feeding behaviors. Because, as you will know, whales live through winters on the fat that they have accumulated during summer. And for lactating females, proper feeding is also a source of milk. So every gram counts. If whales are not properly fed up to winter, this decreases their survival chances, and for females and calves, this negatively affects lactation and nutrition. So we have gray whales, pretty abundant in the Arctic or in subarctic. They are benthic feeders, which implies shallow areas that makes them potential victims of noise that is associated with the development of the Arctic. We have receding sea ice, and there are plans to develop the northern sea route. There's going to be increased activity, and this is a potential threat for this species. This was the range of our research. Bilimbi National Park. And the method was as follows. We played certain sounds to whales, and then they compared before and after. The observation period was about 20 or 80 minutes of observation before exposure. Then we used dedicated underwater speakers at the level of 142 decibels for 1 micropascal at 1 meter. And then we did some follow-up for 20 or 80 minutes. The variables were as follows. We looked at whales that surfaced, and we registered their timing, azimuth, and distance. Then we identified the type of activity. We did observations from land where possible. If whales went near shore, where not, we went out on boats. Types of activity included traveling, where a whale would be moving in the same direction with medium or high speed. Then foraging, where a whale would be moving in different directions. And you could see mud plumes that the whales would stir up. And the third type of activity would be resting, moving slowly, slow breathing. Here is a sample of noise. Let me try and play it back. Anyway, this is standard shipping noise, and horizontally you have frequency, vertical axis is volume, and you see that most of the energy was concentrated in the lower part of the frequency spectrum. Here is the formula that we used to calculate received levels, given that that's underwater and propagation is nonlinear. The next slide is the summary of results. We did 11 experiment observations. That's much fewer than we expected or hoped, but a major limiting factor was to find an individual isolated whale. That species is not considered very social, but when we wanted to actually find an isolated focal whale so that other animals would not interfere with our experiment, this was really hard. As you try to do that, you find out really quickly that they move around in couples or in sets of 3 or even more. So the results are pretty sparse. Still, over the 11 experiments that we carried out, we were able to produce statistically significant differences. We look at breathing timing, we look at changes at speed with which they moved, and we looked at some changes with feeding behavior. And the estimated received volumes were pretty low, by the way. I mentioned the threshold at 120 decibels. And what we have here is down to 105, 103, and it's no more than 109. So these are trajectories across time. Green bubbles show surfacing before exposure to noise. Red dots stand for the time of playback, and then blue dots are follow-up. Experiment 1 shows us a resting whale. It was moving really slowly with regular breathing. After exposure to the sound, we see that they surfaced 2 times at a very short interval. Then the whale went underwater for a long time, and only after a certain time the whale would surface back chaotically at random and then go back to resting. Significant differences were also observed in experiment 3. We have only 2 data points before exposure to sound, because we wanted to identify whether that whale was suited for the experiment. There was another animal close by. This one was foraging. As soon as we were able to isolate it, we played back the sound. It stopped feeding immediately and tried to go away. So this interval that I'm showing between 2 breaths was about 5 minutes. So only 15 minutes after exposure to sound, the whale calmed down and began surfacing as normal. Now on to the conclusions. Obviously, these are preliminary results. We will continue with the research. We'll vary the sound type, we'll vary the duration. But for now, we can state that short exposures of about 5 minutes at low levels can produce observable change in behavior. This means that even such low levels must be accounted for when the routes are actually plotted for the Northern Sea route. This could indeed affect whales, and the propagation range for underwater noise is really long when we speak about shallow waters, so shipping can have a major negative impact on cetaceans. That's it, and thank you. Thank you very much for this presentation, Olga. I see we have 2 questions and we have the time. The first question is from Justin Cook. Please, the floor is yours. He seems to be muted. Well, he had a raised hand. Then let me read out a question from the chat. Can whales accommodate themselves to relatively low levels of noise in different regions? And what would be the safe, quote unquote, level for the animals? Well, of course, they can get used to it. This is another response where whales or any other animal or even humans adapt to most negative factors over long exposures. But is it good or is it bad? There might not be obvious behavioral response, but chronic stress is still there to stay. And another question, how did you plot the trajectories for whales? That's a standard technique. We know our position thanks to GPS. We measure the distance to the whale using a rangefinder, and then we measure azimuth. We have the distance, we have the bearing, and then we just plotted it using the map. Okay, and I see that we have another question from Natalia Krukova. It's going to be asked on the call. My question is this. You did observations in the Chukchi Sea, and it is a whaling area. Did you account for that? Because this could affect the behavior as well. Well, the Northern Sea route is going to go through there as well. That's why we decided to choose that region. And most other locations across the route are also whaling grounds. Well, I suppose the whales would be more reactive as opposed to Sakhalin, maybe, where there is no whale. They are hunted there. That's the reason. Well, if they do it in our case, then the same is going to happen for a real vessel that produces noise. You don't have to compare Sakhalin against Chukchi. I don't mind at all, but there is a lot of nuance there. You know, if it had been quiet and then you begin playing it back loudly, it's very different from a gradual approach by a vessel where the volume goes up gradually as well. Yes, we wanted to do that as well, and we'll be introducing this starting in 2021. Colleagues, I'm sorry. Could we maybe park it until we have the discussion? Yeah, indeed, there is a lot to talk about.
Thank you, colleagues. And now I would like to go back to Olga Filatova. I hope she's still here with us. Olga, can you please tell us, you demonstrated a slide and you had a map of gray whales movements after the noise exposure. And you, as far as I understood, you analyzed the distance between the source of this noise and the specific animals. I would like to know if you are planning a publication where you're going to describe all the details and especially all these quantifiable data, you know, some statistics, because we would like to use it for developing norms. And then there can be some sort of, you know, official recommendation, for example, for oil and gas organizations, because right now they're using international sources and data, but this is not absolutely right. Yeah, because there are specific species living here, and also the certain parameters of the basin, aquatic basin. And if we speak about such a noisy industrial works, so we would like to use your quantifiable data. Thank you very much. Yes, definitely. We are going to publish these results. But first, we would like to collect more statistics. What we did in 2020, I would view it as some preliminary preparatory work, because these noises were quite low. Then we were increasing the volume and the length of the samples. So this was quite limited. We are going to continue this work, and there will be different options, you know, all these noise samples, different in terms of length and the frequency and the sound. Okay, they will be amplified. And when we get, you know, more or less, you know, a big picture, then we will be ready to publish. Because gray whale noise impact, you know, so yeah, so there are no experimental data. There are just some one-off results. Yeah, but for this mega fauna, yeah, so we do have some information in the Barents Sea. Yeah, but this information is not absolutely reliable. Yeah, especially if we speak about bowhead whales. Yeah, because they responded differently. So there was some positive correlation or negative correlation. Sometimes these animals just avoided, yeah, and they swam away. In other cases, these noises attracted them. So I believe such experiments and this research is one of the most important areas because it will enable us to understand how noises affect whales or cetaceans in general. Yes. Yeah, but these controversial or insufficient data, yeah, it is inevitable. Yeah, because we did it with killer whales. Okay, these are live animals. So of course, their response might be different. And it depends on their activity, and maybe if they are resting, it is one thing, and others might respond in a different way. So there are so many additional factors apart from the noise characteristics. That is why, in order to put these elements of the puzzle together, we need to accumulate more data. Because if we want to demonstrate something, then there should be lots of elements registered. Olga, and are you planning to conduct these experiments for other animals, maybe humpback or bowhead whales? Well, during the season, they are far away in the north, so technically it is not quite. Yes, if a bowhead whales, it is not possible, but with humpback whales, maybe. But first, we would like to focus on one species. And bowhead, bowhead, humpback whales, so they usually are in pairs or in small groups.